Hi everyone, I'm Jeffrey He, and today I'll be giving a brief workshop on designing effective technical presentations in graphics. I first want to thank Professor Balsara and Dr. Beshti for inviting me to the class for the guest lecture. And I would also like to thank my former group members, Rosa, Cody, and Sachin, for working through countless all-nighters while making the 154 oral reports. Now, before I start the actual workshop, I want to share the main motive on why I'm giving this presentation today. Throughout my time here at Berkeley, I've realized that my research, or my work, are basically commodities that I have to showcase to the public for desirable results. Whether I want to get published in journals, get accepted to grad schools, or get recruited by companies, I realized that one would have to sell themselves. Like any other company out there in the market, we must also apply the marketing mix in order to sell ourselves better. I like to think CB 154 as a training ground where chemical engineering students here at Berkeley learn both the technical aspects of their discipline in the laboratory form and also the communication skills necessary to deliver the research outcomes in a cohesive and convincing manner. Today, I wish to focus on the latter half, in which I will be explaining strategies to enhance your presentation delivery and making effective visuals and figures for your presentation. Moving on, I assume that most of you have completed the first oral report. I know that making these oral reports are tedious and time consuming, as I've made several in the past. I'm going to assume that most of you have either trouble making the presentation itself or structuring the oral report to form a cohesive storyline, or maybe both. So today, I will be mainly going through the following. First, I will share the way I form my oral report storyline, each for the entire presentation and for single slides. Then I will move on some tips on improving the oral report visuals. Finally, I will share some miscellaneous tips that I don't think necessarily fit in the previous two categories. Okay, first, let's talk about structuring the oral reports. If you go to B courses, there should be a long passage talking about what oral report should be. I know it's long and pretty hard to understand the exact expectations without some experience in the class, so I would like to summarize it for you. First, 154 expects you to answer all or most of the data analysis questions. However, just blankly just answering these data analysis questions, and addressing them individually in your oral report is a big no-no. Instead, these data analysis questions are actually means to reach the main objective of the lab. The main objective of the lab is usually stated in the first section of the lab manual. However, sometimes these objectives are also very subtle. It is your job to read through the data analysis questions and understand the main purpose of the lab. I'll talk more about this main objective later on when I'm doing an example with you guys. Finally, the presentation should be towards inexperienced engineers. So it is okay to use jargon in your presentation, but it is essential to talk about the context and explain all the data analysis steps. So a person with no background knowledge on the experiment would still understand your results. A successful technical presentation must contain all of the following elements. First, one should mention the motivation. This motivation can be the reason why you're doing the lab in the first place. For instance, it might be to understand a certain phenomenon or to optimize a process. In the context of CB154, it would be the reason why you are doing this certain lab. It also could be about the reason why you are investigating and answering each data analysis question. In the CP lab, you are asked to investigate the capacity versus head curve. Why are you looking into this relationship? How does it tie with the entire lab? And how does it refer back to your main objective? Second, you must talk about the existing theories and background knowledge. Science is a discipline where new knowledge builds upon existing results and observations. It may be helpful to talk about some experiments that other peers have completed in the past and transition into what you are trying to do. Are you trying to verify a new existing phenomenon? Or are you trying to observe something new? Or are you trying to conduct a higher sophisticated investigation? It is also important to provide some definitions. While you may assume the professor should know everything about the lab, which they might, it is essential to provide some basic definitions that link back to your data analysis for an effective technical presentation. Third, talk about the methodology. Methodology may be about the experiment apparatus. How did you set up the experiment and your equipment? to investigate the phenomenon in interest. However, it may also be about the series of steps to reach your conclusion. Data is universal, meaning that the numbers obtained in the lab is the same for everyone. However, data can be interpreted differently by everyone based on how you analyze it. Make sure to include your steps on how you analyze your data in your presentation. Next, talk about the results and interpretation. Results are usually shown in the form of graphs and tables, where interpretation is what you gain from looking at those correlations and results. Results are often interpreted by the theories and background knowledge presented before. Lastly, for the conclusion, you must link back your interpretations to the main objective. And using all these oral technical communication elements, you can build an entire oral report. The following is the oral report structure, where you have 10 slides to go through all of the elements on the left. What I like to do is to talk about my motivations and experimental procedure on the first slide, and talk about my conclusions and experimental extensions on the last slide. Using the middle 8 slides, I talk about the results and my interpretation of the data in a very cohesive manner. Let's try an example. Since everyone in CP 154 has done CP by now, we can go over CP. So, what was the motivation behind CP? While the data analysis questions for the CP lab asked you about the relationship between pump efficiency, capacity, and impeller size, the main objective in this lab was actually to characterize the centrifugal pump. Why are you characterizing this? Well, that will be because CPs are ubiquitously used in industrial processes. Why go through an entire lab in CP? That will be because all industrial processes are interested in operating centrifugal pumps in a safe, energy efficient, and inexpensive manner. What about the background? We use the Bernoulli's equation to relate relevant terms in the CP lab. We also introduced several terminologies that must be defined. And we also referred back to existing correlations for centrifugal pumps. For methodology, we use non-dimensionalization. While non-dimensionalization is widely used in the chemical engineering discipline, it still needs some elaboration. Why did you use this technique in this lab? What benefit does it bring? And how did you use this technique to obtain your master curve? What kinds of plots did you make, and why did you make them? What results were you trying to obtain during the lab, and what makes the data analysis questions important questions to answer? After employing your data analysis methodology, your group should have obtained results such as the efficiency versus the capacity relationship curve. What is your interpretation of the relationship that arises? Why do you think this is the case? What are you trying to convey with the plots that you show? Finally, you show the conclusion. The conclusion would be different for every group because the data collected and the interpretation methodology are all different. However, the conclusion of all the labs you conduct should link back to the big story on why you did the lab in the first place. The conclusion element basically is the so what for the entire lab. What is the one sentence you are trying to convey? For instance, my punchline for the CP lab was that modeling CP is essential for industrial process design, but it is only possible with a higher sophisticated analysis, and this higher sophisticated analysis is required to accurately model them. The conclusion, as you can see, should always be linked with the motivation of the entire lab. I summarized the entire lab and the results I obtained in several sentences and color-coded them up here. And while color-coding is unnecessary, it is always a great strategy to write down your data analysis in sentence form, the things that you wrote for your data analysis questions, and link them back into a cohesive storyline. Using this storyline, I can create the slides for my oral report. I use assertive and very brief slide titles to show my storyline. And I also present all of the oral report elements roughly in order to form my narrative. I first present the motivation of the entire lab and my main objective in the CP lab. Then I build on the theory, methodology, results, and interpretation to form a statement. And usually 8 to 9 slides are enough to make 2 or 3 key statements. I combine all the key messages and then present my conclusion of the entire presentation, linking it back to the lab's motivation. Now, of course, this strategy is applicable to any of the oral reports or any technical presentation that you'll do in the future. The key takeaway is that in order to make the audience engaged in your presentation and understand the most, you need to devote a lot of time and effort telling them the big story rather than telling them all the nitty-gritty details. Forming a cohesive story for any presentation is hard at first, but with enough practice, it becomes second nature. Using the storyline of the entire presentation, you now must be able to structure your individual slides. Fortunately, structuring each slide is very similar to the aforementioned procedure. In every slide, you still need to elaborate on your 6 oral report elements. But first, let's look at the methodology slide. Usually, this slide is my first slide of the entire oral report. First, I start off with a sort of title on the main focus of the entire presentation. I then show a sentence on my goals of the experiment. Usually, the goal targets a more specific objective than the motivation. For instance, in this experiment, the main objective was to investigate several flow meters and how we can use them in different situations. In order to do that, one must be able to know the unique pros and cons of each flow meter, so that was basically my specific goal. I then present an illustration of the experiment apparatus. Sometimes these diagrams are provided in the lab manual, but I also like to draw them from scratch. I then finally present the independent, dependent variables and the phenomena I'm trying to observe. The final aspect of the slide is the data analysis methodology that I've been talking about previously. Using this technique, I'm able to make the methodology slide for any CB154 lab. For instance, this would be my sucrose inversion lab or report methodology slide. Let's do another example for data analysis slide. I always start off with a blank slide with just the title because this is the final conclusion I'm trying to reach with this slide. I specify the data analysis question I'm trying to answer as my motivation and explain why I'm interested in answering such data analysis question. I then show the methodology of the analysis that this slide contains. For instance, for the slide above, I define the sucrose conversion because I will be using the concept throughout my entire presentation. I then show the relevant background knowledge to my slide. Since I'm trying to show how chemical reactions are carried out and what factors may influence X, I discuss the collision theory and what active sites are. During the presentation, I'm just briefly mentioning these concepts because I expect the audience to vaguely know what they are, but I don't want to blindly assume they know all the specific details. After presenting the background, I'll show the results in the data analysis I conducted with my methodology. The results portion is shown as a graph on the right, whereas the interpretation is contained in the caption below the raw data. Sometimes I like to include a few more text boxes to link between an interpretation and theory, just like how I talked about the temperature dependence of the chemical reaction conversion on the bottom left. Lastly but not least, I make sure to connect my result interpretation to the slide's title. I explain how my results either verify or go against my initial hypothesis, and how it links to my entire presentation. I like to call these titles punchlines. It is the message you want to convey. Punchlines not only exist in the forms of titles, but also figures in your plots. Since you are limited to 15 minutes and 10 slides during your oral report presentation, it is essential to carefully choose what you want to say. By selecting the most important punchlines or statements that you must mention for your story to flow, you would be able to present your results in a cohesive and non-cluttered manner. Whenever I'm making my oral reports or any technical presentation, I like to use outlines and brainstorm how I will order and select these punchlines. Usually this outline is a brief sketch on my iPad or a piece of paper, but regardless of the format, it definitely reduces the amount of time I use to form my storyline and also making the presentation. In the past, many people have asked me how I design the figures or illustrations on my presentations. Yes, most of the figures I use are self-made, and I included a YouTube link in this presentation that takes you to the workshop video. I'll now move on to some of the techniques I use to make my oral reports. These techniques include some shortcuts to making aesthetically looking presentations and methods to emphasize your message. Namely, I will present about the 4 techniques labeled up here: composition and visual weight, animations and transitions, typography, and color schemes. First, I would like to talk about the slide composition and visual weight. Oftentimes, presentations are packed with too much information. Informative slides aren't usually a problem unless they are presented in a very visually compact way. Most of the time, problematic technical presentations have their text boxes and figures all over the place in an unaligned manner. Since the figures aren't distributed throughout the slide properly, it makes the audience have a hard time interpreting the slide. PowerPoint presentations are made to present data and conclusions in a simplified and easy interpreted manner. However, if the figures are too close to each other, without any white space, it is very difficult to determine what the hierarchy or order between these figures are. So, to prevent this from happening, I suggest everyone to use guidelines. Guidelines are found in all presentation applications. Adobe products also have an auto alignment function that are useful for very detailed design. As you can see, I transferred my outline sketch on the bottom right corner onto the Google Slides using guidelines. All of the figures and text boxes are placed carefully so the audience doesn't have to study the slide to understand what I'm trying to say. The second strategy is to use animations and transitions. Unlike written reports and papers, presentations are designed to be dynamic. The following slide is a slide from my CB 160 final project where I present a process flow diagram on one slide. While pointing to specific parts on the diagram on a stationary image may be difficult, since I color coded my image and also use animations, I am able to convey a cohesive story without much effort. Animations and transitions basically make the slide excellent for storytelling. Also, for those who have struggled to include all of their results in 10 slides, animations can provide you free real estate. Introducing new figures on the same page by layering them over other figures, you can basically make your 10 slides into 11 or 12 or even more slides. Here are some slides I employed transitions in. Whenever I'm making these presentations, I also like to add in presenter notes that contain cue signs on when I should press space to move on to the next animation, and it allows you to convey a much more cohesive story. Next, I want to shortly touch upon typography. The punchline of this slide is that even for the same text, depending on the font, different shapes can appear on your screen. For instance, when I'm trying to type the character 1 onto the screen, while Lato and Cambria show a very clear 1, Gil Sans prints a character that can be misinterpreted as an L or an I. So selecting good fonts for presentations is very important because you never want the audience to get confused between what you are trying to show on the screen with what you are actually saying. Unicode hex inputs are also very useful when typing mathematical texts in string form onto your presentation. I've included a tutorial on a past video uploaded to YouTube, which I will also link below. Basically, using Unicode hex input, I'm able to type complex characters in string form with ease. All characters have their own unique Unicode, and by knowing what their unique codes are, you'll be able to enrich your text boxes with relevant symbols. By using Unicode hex input, I'm able to type these two expressions that contain complex characters that are not necessarily found on your ordinary keyboard with ease and without using external applications. So assuming that I have Unicode hex input set on my computer, I'm able to write down the reference mark by pressing down option 203B, and voila, you get the reference sign. I write down reactor temperature as I would as any other ordinary keyboard. And for the plus minus sign, I'm again pressing down option 00B1. I'm pressing down option while I'm typing the 4 digits, and I keep going. For the Celsius sign, it would be option 2103. Let's do another example. For increased pressure drop, I can write the circle 1 character by pressing that option 2460. I write increased pressure drop. And for the delta sign, I do 0394. P, and then for the up arrow, I do option 2191. And the good thing about Unicode hex input is that all the characters that you type out are basically string files where you can bold them, you can underline them, you can italicize them, um, if there are inputs for those different functions. Lastly, for typography, I would like to introduce LaTeX syntax. LaTeX syntax is often used to type technical documents. Oftentimes, online platforms like Overleaf or local applications are used to type documents that contain a lot of mathematical expressions. However, there are other applications that export PNG or PDF files of LaTeX expressions when you input the syntax. LaTeX and KLaTeX Formula are two useful apps that I've used in the past to obtain these expressions. I've included some LaTeX syntax on the right. And honestly, learning the syntax does not take that long, and probably up to 5 minutes max. And definitely learning the LaTeX syntax has been a great help in my academic career. This is a LaTeX syntax demonstration. Say that I'm trying to type the time-independent Schrodinger equation onto my slides. And this is what I found on the Google Images. However, since this images is pixelated, I would like to write down my own LaTeX syntax and create my own PNG so I can put it into my slides. So assuming that I have LaTeX it downloaded onto my computer and that I know the LaTeX syntax for the relevant characters on in the equation, I can basically just write down the syntax and get the formula. Now, as you can see, I already have the time-independent Schrodinger equation on the right. But now, let's say I want to have more flexibility with this equation, where I'm not using the wave function psi, but I'm actually using phi. Well, it's easy because I have full control over this LaTeX syntax, where I just change all the psi's into phi's, and then I have this new equation. I can just drag this out in the form of PDF or PNG or any other image file and put it onto my screen, and voila, there is the expression. Now assume that I'm not looking into this equation in 3D, and I'm looking into 2D. I'm going to change the gradient into another fraction where I'm using only the x direction, and there you go. You have another equation just by typing it out. The last aspect I want to touch upon are color schemes. The first color scheme is the discrete color scheme, where each color is represented by their own names. When showing categorical discrete distributions, using this color scheme would be helpful. However, color schemes are often used to show a gradient in technical communications. Namely, the bifocal over white scheme and the mono-hue scheme are the most widely used color schemes recently, due to an inclusion act in academia, even for colorblind people. Bifocal over white schemes are often used to show temperature gradients, where the red color represents the hot temperatures and the blue represents the cold temperatures. For other gradients, mono-hue schemes are often employed, and the difference in saturations of a single color are often used to show energy, heights, concentration, and other gradients. Here in my slide in this Sucrose Inversion Lab, I used the bifocal over white scheme, and by using this color gradient, I was able to introduce the idea of phenomena regimes that arise from dimensionless analyses with ease. I often enjoy using the mono-hue scheme as well, and use the base color of blue. And then I also put in my own spice by using the red color to emphasize certain parts of my illustration if needed. Sometimes you might need to create visual contrast using different colors for slideshows. If you have more than 3 colors, the figure usually gets too complicated, so I suggest looking into other parameters, including transparency, patterns, and borders, rather than just changing the colors. As I end off my guide to making effective technical presentations, I want to share some miscellaneous tips for CB154. As a disclaimer, these tips are what I've accrued over the entire semester and might not work for everyone. First, when doing data analysis, rather than working in collaboration with the entire group, I suggest everyone does it individually. In my experience, the most frustrating part of CB 154 OR reports is when you realize you did the data analysis incorrectly the night before your OR report, and this often occurs when different questions are divided up between the group. By doing the calculation separately and matching with each other at the end, the entire group can choose the best methodology on analyzing their data and also reduce the chance of running into calculation errors. Also, most importantly, everyone can be prepared for the Q&A questions, especially the hard curveball questions. The second tip is to use their appendices. Usually, the 10 pages aren't enough to contain all of your mathematical derivations and all your other your data analysis, but by using these appendices, you are able to include extra information onto your slides. And whenever the professor asks you Q&A questions during the Q&A session, you can always be prepared by turning over to the relevant appendices slides to talk about to answer the question. Third, I want to emphasize the importance of pre-lab questions. Usually, the important aspects to the lab or the main motivations are included in the pre-lab questions, and these pre-lab questions are often asked during the Q&A sessions as well. Lastly, but not least, always understand that your experiment and the raw data that you collected during your CB 154 lab are subjected to methodological errors. Methodological errors are errors that rise from the experimental setup, and because we live in a non-ideal world, these experimental apparatuses are not always perfect. By taking pictures during the lab session and also realizing the flaws and the limitations of the apparatus, you'll be able to better reason why you obtain bad data in your lab, or why you might have some deviation from ideality. Thank you, everyone. I just wanted to thank everyone listening through this workshop, and the YouTube video that I've talked throughout the entire presentation is linked here. Thank you.